Hey, so we've got this problem and we've got a lot of different parts. So we have f of x is equal to the cube root of 2x minus 5x squared. All right. The first thing we want to do is we want to find the domain. So when we're looking at the domain um, for problems like this, if this was a square root, not a cube root, we would do the stuff inside greater than or equal to 0. But if you remember what the graph of the cube root looks like, it looks like this, a little bit like this. It might be off a little bit or something, but it looks something like this. So for every x value, there's a y value. Even for 0, there's a 0. For every x value, there's a y. So our domain goes from negative infinity to positive infinity. All right, so that's our domain. Now we need to determine whether or not the function is even or odd or neither. All right, so f of negative x equal to f of x implies that f of x is even. F of negative x equal to negative f of x implies f of x is odd. All right, so we're going to plug in negative x and see what we get. So f of negative x equals the cube root of 2 times negative x minus 5 times negative x squared. All right, so this is the cube root of negative 2x minus 5x squared, because the negative squared doesn't do anything. All right. So it looks like it's going to be neither, because this is not equal to negative f of x, and it's not equal to f of x. So it's going to be neither. Neither. T-H-U. All right. Then it asks, what are the roots? We just did is it even, odd, or neither? So now it's asking, what are the roots? So we're going to set the cube root of 2 minus x, 2x minus 5x squared equal to 0, and solve for x. So I can cube both sides, and I'm going to get 2x minus 5x squared equals 0. All right. And then I'm going to pull a common x out, and I'm going to get x times 2 minus 5x equals 0. All right. Now I'm going to set each of these equal to 0. So I have x equals 0, or 2 minus 5x is equal to 0. On this right equation right here, I'm going to subtract 2 to both sides. Negative 5x equals negative 2. X equals negative 2 over negative 5. Let me scroll down some. Over negative 5. A negative over a negative makes a positive. So we have our roots are 0 and 2/5. Right? These are also our x-intercepts, because the x-intercept is where it crosses is where our function crosses the x-axis. Or that's whenever our g of x equals 0. So we just did that right here. So this is the same for our x-intercepts. And then the y-intercept is whenever x is equal to 0. So we're going to plug in 0. So we have f of 0 is equal to square root of 2 times 0 minus 5 times 0 squared, which is just 0. So 0 is our y-intercept. And then to find our f inverse function, we're going to start with f of x equals the cube root of 2x minus 5x squared. All right. I'm going to replace this f of x with y. I'm going to replace this f of x with y, and I'm going to get cube root of 2x minus 5x squared. Now I'm going to flip my x's and y's, and I'm going to get x is equal to the cube root of 2y minus 5y squared. All right. So now that I've done that, I'm going to try and solve for y and get y by itself. So I'm going to cube both sides, cubed, and I'm going to get x cubed equals 2y minus 5y squared. All right. I can pull out a common y. I'm going to get x cubed equals 2 minus 5y times y. All right. So whenever we pull this out and we get this equation like this tells us that we won't have an inverse function for this because we have two y's here and they're being multiplied together. So that tells us there's not an inverse function, because if we were to divide by this term right here, we would have x cubed over 2 minus 5y equals y. And then we have y in terms of y, which doesn't really make sense whenever we're trying to figure out a function, because we can't have a function in terms of itself. It's kind of silly notation. So there is no inverse function.